right, here we go. I got to show you a couple rules. The first rule looks like this. All this stuff up here, guys, this is like math language. You don't have to write that down. This is math language. If b is a positive real number other than 1, then b to the x equals b to the y, if and only if x equals y. So you might be able to read that and think, oh yeah, that makes perfect sense. You might be able to read that and think, I don't even know what that means. Not at all. So that's okay. That's all right. It's all good. So you don't have to write that down, okay? In normal person terms, this is what it means. If you have this, 3 to the x equals 3 to the 5th, that must mean that x is 5, right? Because the base is the same. So for 3 to the x to be 3 to the 5, x has to be 5, right? Because the bases are the same. That's the rule. Here's how we use this rule to solve something, okay? Here's a statement. Here's a statement off this rule that might be helpful. If the bases are the same, then we can drop the base. Yes. Indeed, drop the base. Well, let me show you one. Let me show you one. Oh, there's going to be lots of jokes today. Don't even worry. You haven't even gotten to the log part. We're going to drop some logs later, okay? Don't even worry about jokes. They're coming. Why? That's just human nature. There's nothing funnier than poop. That's funny. Yeah. All right, here you go. Here's the equation. My question is this. Are the bases the same? No. It's 4 and 16. So I can't drop the base because they're not the same. So the thing we got to figure out is, can I somehow rewrite them to make them the same? Well, I don't want to divide anything. I don't want to change anything. I just want to rewrite it. Okay, so put the 2 adds down and the 16 out. Like what? Sort of. I think you guys are on the right track. Can you rewrite 16 as 4 something? Yeah, 4 times 4, or 4 squared, perhaps, right? So what if we just rewrote it as 4 squared raised to the 2x plus 8? That's the same thing, right? You guys agree with me that I didn't change the value, I just rewrote it? You okay with that? All right, so I need to try to simplify this a little bit. This is a power raised to another power. When you have a power raised to a power, what do you do with them? You multiply them. Remember, those are those exponent rules from like a month ago. Those aren't going away. So power to a power means multiply. So over here, we'll do this real quick. I got to do 2 times 2x plus 8. That means I got to distribute. Indeed. All right, so now I got 4 to the 2x. And then I have 4 to that thing. 4x plus 16. Are you comfortable with all that? Yeah. Well, are they the same base now? Yes, they are. It's a 4 and a 4, same base. Now that they're the same base, you can channel your inner DJ and drop the base. You don't like it? Really? DJ. I don't DJ, but I go far when the base drops. What's a good, what DJ names do we have in here? DJ Slayer. I think Slayer likes that. I'll ask him later. When they do, I'll ask him. DJ, DJ, I'm trying to figure out a DJ name for somebody. Yes. You're going to drop the base, and then the stuff that's in the exponent is left over. It's just an equation now. Was that an air horn? Drop the base, now you're just left with the exponents. Are you going to say that do that every time I say drop the base? Okay. I'm not going to say it anymore. What are you going to do when I say drop logs? I don't think that works for dropping logs, though. You have to do something else of a more bodily variety. Okay. We're going to solve this, guys. Hopefully you're getting to the point where you can solve equations like pretty quickly. Subtract 4, divide by a -2. There you go. From here to here, I subtracted 4x. Which part? Good timing. Good timing. All right. So guys, big takeaway from this one. Here's the big takeaway you need. If the bases are the same, yes. Exactly. Let's say, I'm going to give you a different one, okay? Let's say you have one that looks like this. Do those have the same base? No. Can you somehow write 7 as 2 to some power? I don't know. Probably not. It's 2 to something. But, so here's the problem. We can't do what we did before, right? I can't rewrite this with a 2 so that I can get rid of them. I can't do that. All right, so guys, the thing that we're talking about today, students find it confusing. Often they have a hard time solving these types of equations. Here's the big, you're not Slayer slays it, okay? Here's the pro tip that I can give you, okay? This is the pro tip, the best piece of advice I can give you on solving these. Every time you solve an exponential or log equation, you are going to transform it from one form to the other. Like if it's an exponential, we're going to turn it into a log. And if it's a log, we're going to turn it into an exponential. You're always going to do that, okay? So like this is an exponential, and I don't know what to do. I don't know how to solve it, okay? So instead of giving up, when you get stuck and you don't know what to do, transform it into the other form, which is what this says. When you're solving an exponential, you can't figure it out, transform it. Here's what I mean. I can't solve this thing, so I'm going to transform it into a log. How do I transform this into a log? Yeah, you're bringing the base over. Remember, guys, hopefully we know how to transform from log to exponential. It's going to be x equals log base 2 of 7. Remember, the base of the exponential is the base of the log and vice versa. Okay? Like in the log, it's just there. It's just there. All right. So guys, I told you, I don't remember when this was. I don't remember which lesson this was a part of. I think it was all the log rules. There's a way you can figure out what this number is. You can figure it out in your calculator. Because remember, this is asking you what power do you need to raise 2 to get 7. Your calculator will tell you what it is. Do you remember how to do it? Kind of? Okay. What is it? Yes, so in your calculator, you have a log button, right? You need to do log of the top number divided by log of the bottom number. That's called the change of base formula. And it's some decimal. What is it? 2.81. So you can evaluate this in your calculator. You just do log of the top number divided by log of the bottom number. Okay? And that's it. That's your solution. That's it. Bummer. That make a little bit of sense. So, big takeaway. If you're solving an exponential and you get stuck and you don't know what to do, don't cry. Turn it into a log, okay? Turn it into a log and you'll probably be able to figure it out. Try these. Try these, go. Let me show you what we're talking about. We're dropping logs. Again, math language. You don't need to write that down if that's not helpful for you. This is what it is in normal person language. If you have log base 2 of x equals log base 2 of 7, you can drop the logs. Okay? Why do you think I can drop these? Because they have the same base. It's log 2. So they're gone, and it's x equals 7. Does that make sense? You can only do it if the base is the same. Okay? It's the same thing as exponentials, except now we're talking logs. So this thing, log of that equals log of this. Are these the same logs? Yeah, just for good measure. What's the base of these logs? It's 10 because there's nothing written, right? So, since the logs are the same, you can drop the logs. 4x minus 7 equals x plus 5. Yep, absolutely. Absolutely. All right, now you're solving this. Subtract x, add 7, divide 3, boom. Hey, can you drop these logs? Yes. They're the same, right? Gone. So then you're just solving that. Is this making a little bit of sense? Okay, for sake of time, we're not going to finish this one because I trust your ability to solve that equation. All right? Yep, I do. I do indeed. So I got to show you the scenario that's a little bit more funky, okay? It's this scenario. You got that. Log base 2 of 5x minus 17 equals 3. Can you drop that log? No, you can't. You can't just go dropping logs everywhere, okay? Yes. I hope not. I can't get rid of this because you need the same exact log on the other side. Since there's not, I can't just go crossing stuff out. Okay, that's not how it works. Well, can you rewrite this with a log? I don't think so. I don't think you can. So again, pro tip. You are always going to switch back and forth one way or the other. Okay, so before we had an exponential equation that we didn't know how to solve. So when we got stuck, we didn't cry, we didn't give up, we didn't freak out. We turned it into a log, okay? And it's going to be the same thing here. Now I have a log. I don't know what to do, okay? Here's what you're not going to do. You're not going to call your mom. You're not going to. You're not going to freak out. You're going to transform it into an exponential. Just go the other way. So let's see what it looks like. Log base 2, 5x minus 17 equals 3. Turn it into an exponential. What's it going to look like as an exponential? Two to the third. So guys, we need to be able to transform these, okay? If we're still struggling with this, we're going to have a hard time. Take the base, move it over. It's going to be 5x minus 17 equals, remember the base gets jammed up underneath. Wow. It won't be for a while. Yeah. Come on. Come on. All right. Guys, do you see how I went from this to this? All poop jokes aside. Because we have to be able to do this. We have to be able to do this, okay? Now we're just going to solve this. What's 2 to the third power? Okay, so now I'm just solving. You're going to add 17. You're going to divide by 5. And there you go. There's x. Does that make a little bit of sense? So again, pro tip. You are always going to switch from one form to the other. If it's an exponential, it'll get turned into a log. And if it's a log, you get turned into an exponential. When you get stuck, just switch it, and it'll probably work, okay? So try some. Here we go. Mr. Smith, though he has no money to invest, is still hoping to become a master investor. So I somehow invest $2,300 in a corporate bond that pays 14% compounded continuously. How long will it take for the bond to be worth $6,000? Huh? Cooking the books? This is bad. You think it's a bad investment? Yeah, it's pretty big. It's pretty big. Pretty big. I'm going to show you. All right, so guys, if you remember, we did all these crazy word problems, and then when I first showed you what a logarithm is, I showed you a word problem like this that we got to a place where we couldn't solve it. I don't know if you remember that, but that was how we first started talking about logs. We were doing one of these, and we were like, oh, we don't know how to do this, so we need this thing called a logarithm. Well, this is that same type of problem because now we know how to solve it. All right, so let's break it down. What equation am I using? How do you know it's PERT? Because it says compounded continuously. So we have PERT. Let's see what we have. What is 2300 representing? That's the principal, that's P. I have a rate. What's the rate going to be? Well, it's 14%, but I need it as a decimal, right? So 0.14. What is 6,000? That's the final amount, right? So that's A. So what am I trying to find? Yeah, how long will it take? I don't know what T is. That's what I'm trying to get. So let's put everything in that we know. We know A is 6,000. We know P is 2,300. We have E raised to the RT, so that's 0.14T. That's all the information we have. So now I'm trying to solve for t, okay? So it's an exponential. I'm going to have to solve it. I got to get this piece alone first. So what would you want to do? Divide by 2300, get rid of that on both sides. So what's 6,000 divided by 2300? Calculator, somebody. 2.608 is e to the 0.14t. Okay. So far, so good? So I did this, I got that. I have e to the 0.14t. It's an exponential. I want to turn it into a log, right? So what's it going to be? ln, right? I'm going to take the e, I'm going to move it over. It's ln 2.608 equals 0.14t. Yeah, are we okay with that? Okay. Cool with me. Well, this is just a number. You can figure out what it is in your calculator. What do you need to do to get t? Divided by 0.14. So you're going to do ln of this in your calculator, and then divide it by 0.14, and it'll get you a number. What is that number? 6.847. And that's time. Years. I mean, it more than doubled. All right, so now you know how to solve these ones that we didn't know before, because now we know what a log is.